My name is Sai Teja. I am from Tribly department. Today topic is about PN junction diode and VI characteristics of a PN junction diode. PN junction diode. The PN junction diode is the cornerstone of semiconductor electronics, and its detailed study offers insight into a construction, operation, and application. Below you will find an in-depth analysis encompassing advanced details. A PN junction diode is formed by joining P-type and N-type semiconductor material. It allows current flows in one direction, forward bias, and blocks in opposite direction, reverse bias. It acts as a unidirectional switch. PN junction diode. Formation of PN junction diode. P-type semiconductor and N-type semiconductor. In P-type semiconductor, doped with trivalent element. Example, boron. Majority carriers are holes, positive charge carriers. Minority carriers are electrons. In the N-type semiconductor, doped with pentavalent element. Example, phosphorus. Majority carriers, electrons. Negative charge carriers. Minority carriers, holes. To form a PN junction diode, P-type semiconductor and N-type semiconductor are very important. PN junction diode contacting with two material, diffusion process, recombination, depletion region, built-in potential. Diffusion process. Electrons from the N side diffuse into the P side. Holes from the P side diffuses into the N side. Recombination. Electrons and holes recombine near the junction, leaving behind fixing donor ions, positive, on the N side, acceptor ions, negative, on the P side. Depletion region. A region devoid of free carriers forms near the junction, acts as a barrier to further diffusion. Built-in potential. The electric field created across the depletion region results built-in. Example, similarly 0.7 volts for silicon and similarly 0.3 volts for germanium. PN junction diode. Working principle of a PN junction diode. Unbiased diode, forward bias, reverse bias. Unbiased diode. Without any external voltage, the diode is in equilibrium. The built-in potential prevents the flow of majority carriers. A small current flow due to thermally generated minority carriers. Forward bias. Positively terminal of the battery is connected to the P side and negative terminal is connected to the N side. The applied voltage reduces the width of the depletion region and lower potential barrier at a specific voltage threshold. PN junction diode. Working of a PN junction diode. Unbiased diode. Without any external voltage, the diode is equilibrium. The built-in potential prevents the flow of majority carriers. A small current flows due to thermally generated minority carriers. Forward bias. The positive terminal of the battery is connected to the P side and negative terminal is connected to the N side. Here, the diode the diode positive is connected to the positive side of diode. And the positive is connected to the positive terminal of the battery and negative is connected to the negative terminal of the battery. It acts as Forward bias. The applied voltage reduces the width of the depletion region and lower the potential barrier. At specific voltage, the threshold voltage current starts flows significantly. Threshold voltage for silicon similarly zero point 0.7 and for germanium similarly zero point 0.3 volts. Reverse bias. In the reverse bias, the positive terminal of the diode is connected to the negative terminal of the battery. In this image, we can see how the diode is connected to the battery in reverse bias. The positive terminal is connected to the negative terminal of diode and positive terminal of the diode is connected to the negative terminal of the battery. In this case, the current will be not flow through the diode. Positive terminal of the battery is connected to the inside and the negative terminal to the P side. The applied voltage increases the width of the diffusion region and raises the potential. Here is characteristics of PN junction diode. Forward bias region, reverse bias region, breakdown region. Forward bias region. Below the threshold voltage, current is negligible. Beyond the threshold voltage, the current increases exponentially. Reverse bias region. Small leakage current flows due to minority carriers. Current remains constant until breakdown voltage is reached. Breakdown region. Reverse current increases sharply behind the breakdown voltages. Mathematical representation. Forward bias. I is equals to Is multiplied by E exponential QV by KT minus 1, where I is the diode current, Is is the reverse saturation current, Q is the electron charge, V is the applied voltage, K is the Boltzmann constant, T is the absolute temperature. Reverse bias. I is equals to Is. Leakage current. Is is typically in the nanoampere range. Breakdown. With breakdown voltage, current increases sharply. Breakdown can be due to Zener breakdown. High electric field causes tuning tunneling of electrons. Avalanche breakdown. High energy carriers ion atoms creating more carriers. Graphical representation of VI characteristics. X-axis voltage forward and reverse bias. Y-axis current forward and reverse bias. Forward bias exponential rises after threshold voltage. Reverse bias flat leakage current allowed by sharp increases at breakdown. Here we can see the VI characteristic graph representation. Factors affecting of VI characteristics. Material. Silicon diode have higher forward voltage and lower leakage current compared to germanium diode. Temperature. Forward voltage decreases with an increase in temperature. Reverse saturation current increases with temperature. Doping level. Heavily doped diodes have lower breakdown voltages. Size of the diode. Larger diode handles higher currents. Applications of PN junction diode. Rectification converts AC to DC in power supplies using half-wave rectifier, full-wave rectifier, bridge rectifier. Signal processing, flipping circuits, clamping circuit. Limit signal voltage to desired level. Shift the signal voltage level. Thank you.